Theorem: a perpendicular drawn from the center of a circle on its chord bisects the chord. So according to the statement, we are drawing the figure of a circle. So what is given here? A perpendicular drawn from the center of a circle on its chord. This is the given part. So we have a circle in which there is a chord and there is a center. So just we have written segment AB is a chord of the circle with center O, and the perpendicular is drawn from the center on the chord. So we have drawn segment OM perpendicular to the chord AB. So what we have to prove? The perpendicular bisects the chord. So this perpendicular OM, when we draw on the chord, it divides segment AB into two equal parts, segment AM and BM. This is what we have to prove. Children, we have studied previously that if we have to prove two segments or two angles congruent, we have to first prove the two triangles congruent. So since here we have to prove two segments congruent, we have to prove two triangles congruent. Actually we don't have two triangles here. So what we are going to do here, we are going to join OA and OB and we will get the two triangles. Here we have joined segment OA and segment OB and we have started writing the proof. Draw segment OA and segment OB so that we get two triangles. Don't forget that we have to prove these two triangles congruent, then we will get the two segments congruent. Now to prove two triangles congruent, we use different tests. Now as we know that any test has three congruent elements. So in these two triangles, we have to first of all identify the three congruent elements. Now I have made markings on the congruent element. Now I have written the elements here once again. As you can see, in triangle OMA and triangle OMB, we have to take the correct correspondence. As you all know, angle OMA congruent to angle OMB, segment OM perpendicular to chord AB, seg AO congruent to seg BO, radii of same circle, seg OM congruent to seg OM, common side, and triangle OMA congruent to triangle OMB. So dear children, I have written the test, hypotenuse side test, and since these two triangles are congruent, we get the corresponding sides congruent, AM congruent to BM, just what we wanted. And the reason, as you all know, CSCT, that means corresponding sides of congruent triangle. This is our theorem.